Hello, I'm Arthur. Welcome to my lab. This is my Printrbot Simple. For years, this used to be my go-to printer for precision prints. It's a really nice printer. This is actually the second printer that I built. I bought it as a kit and put it together. And this helped me a lot to learn about how 3D printers work. But over the years, this printer went through many hours of printing and it started showing its age. The wooden parts that it's built of started drying out and kind of coming apart, so I had to retighten this printer several times. And then the printer, the X and Y axes are driven by a fishing line. This little line here that wraps around the motor shaft is what drives the movement of X and Y axis. And this line just wore out over the time. So I tried replacing it with a new line. Problem is that this is a certain specific kind of fishing line that is non-stretching, and it can handle up to 200 pounds of weight. This kind of fishing line is kind of difficult to find, and especially at reasonable prices, and I only needed a few inches of this line, and it usually comes in spools of 100+ feet, so a lot of fishing line that I don't really need. So I was thinking about replacing this fishing line with, well, I tried replacing it with a different kind that can handle a lesser load, and it seemed to work okay. I was thinking about then replacing it with a belt drive system, just redo this whole assembly a little bit to use a tooth gear and put a belt in here and drive this assembly like that, and also do the same for the other axis. But then I've discovered the Hypercube printer, and I love the design so much that I've decided to turn my Printrbot into the Hypercube. Basically, I'll take this printer apart, I'll see which parts out of it I can reuse in Hypercube design, and build a little desktop-sized 3D printer for finer prints using the Hypercube-style design. So let's get to it. Let's start taking it apart. The first thing that I'll do is use my Z drive motor to actually drive this whole assembly off of the rails here, so that I don't have to do it by hand. If you hear a little whine of a motor, that's my extruder motor cooling fan, which is one of the add-ons that I did on this printer. And that was because this motor was getting so hot and transferring that heat to the shaft and the pulley that drives the filament, so that the filament would, for the short period that it made contact, it would get heated up enough to start bending, and I was actually getting jams in this extruder because of that, because of overheating. So that's why I kind of don't really like the direct drive designs, and I really like how Hypercube used remote Bowden drive, which I was hesitant to start using because I was concerned about the precision of control of extrusion, but it actually works excellent. It's a great design, Bowden design. Remote extrusion works just perfectly well. So yeah, the new printer will not have a direct drive, which means that I know already that I won't be able to use my hot end from this printer, because this design of hot end doesn't really allow Bowden connection. I would have to re-drill and re-tap this extruder, and the tips for it are kind of hard to find. So I'm just going to not use this one and use your regular E3D version 6 hot end, which there's plenty of nozzles for that one, and you can use whatever size you want. I will probably go with 0.2 millimeter nozzle for higher precision, finer prints. All right, time to turn this puppy off and start taking it apart. Another thing that I did with this printer is I added the heated bed, and that improved my ability to make larger prints tremendously. Before that, before I had heated bed, and as you can see, the glass that I put on it cracked, but that didn't prevent this printer from printing at all. So I just kept that glass until it cracked to the point that I wasn't able to use it. So before putting a heated bed on this printer, I couldn't really make larger prints because they would just peel off, pop off the heated bed. So to me, heated bed is a really important aspect of a good 3D printer. I would not want to use a printer without a heated bed. And I see a lot of cheap designs these days come out which don't include heated bed. And yes, people use all kinds of trickery, glue, tape, all kinds of other stuff to make their prints stick, which I guess works for many and in many cases. But still, I think there's no substitute for heated bed really. And if you want to have really good outcome, then the heated bed is the way to go. So I think I'm going to speed up this video. I'm slowly learning how to edit videos on YouTube. So I've discovered that there's a feature to speed up your videos. So you probably don't want to really watch in real time me unscrewing all these little screws and taking this thing apart. So I'll either cut this video short and just show you what the outcome is, or I'll just speed up through it. So I won't be talking too much because that will probably be lost once I start editing. Oh boy, I wish putting this printer together was as quick and easy as taking it apart. Putting it together took a lot longer. I had to figure out a bunch of things. The instructions had changed, or they were probably actually an old version relative to the printer that or the kit that I received, because I think my kit was like the second or third revision of the original design, where the instructions were lagging behind. But anyway, here we are, a bunch of parts. I think I'm going to have a couple more grinding attachments for my Dremel. So this is one of the axis motors. This is the other one. I'm guessing this must have been the Y, because it's bigger than the Z, which only had to drive the table. So that's the smallest motor of the 4 that we have. That's the Y axis, a little bit bigger. Then this is the Z axis with the flexible coupling. And the extruder motor, which is probably the biggest and the strongest of the 4, although it looks the same actually as the Z and Y. Let's see, is that the same model number? Yeah, looks the same. 1124090 7220. Kaizen is the brand name, the manufacturer. These are well-known motors. A lot of 3D printer designs mention this brand. They recommend that this brand is used. So unsurprisingly, Printrbot people decided to use this known, good and reliable motor. I was not going to use this motor for my Hypercube because it can work with a lot smaller and weaker motors, but I'll think about that. I was thinking about just keeping this motor to use it somewhere else on some bigger printer. I might actually do that. Use these 3 for another printer that I will be building, and then use some smaller motors that I have in their place on this redesigned Printrbot Hypercube. So again, I'm trying to recycle as much of the Printrbot, as many parts as I can, but I will probably eventually reuse these parts even if I don't reuse them on the Printrbot. Here we have the main PCB, main controller, and this is just a little connection that I added. I had to tap into the power input for my extruder motor heating or cooling fan. Now that I look at this board, I notice that they have these trim pots to adjust the current to the motors. So maybe I could have adjusted the current to the motor, but then the motor wouldn't be as strong and it might struggle extruding. So it's a really tricky balance between getting as much power as you need delivered to the motor so that it can extrude easily, doesn't struggle with the extrusion, and your layers aren't thinned by that, and the heat that's generated. Theoretically, the operating range for stepper motor is up to 50 degrees Celsius. So the motor may heat up to 50 degrees Celsius, and that's considered normal, and that's to be expected. But for the filament, 50 degrees Celsius is getting pretty close to becoming soft and flexible, which then would cause the filament, as it was pushed down by the motor, to kind of, once it heats up here from the motor shaft and this pulley, it would then bundle up here right before entering the rest of the assembly. So that was the problem. That's why I needed the fan. So looks like actually the current can be adjusted, which may come in handy as I build this new version of printer with new motors, which may operate at different current settings. And yeah, I'm going to reuse this controller for the new printer. I'm hoping to be able to reuse the threaded rod with its Teflon nut. And then I'm hoping to reuse at least some of these smooth rods. If I don't use them for this new design, then again, I'll just put them in my inventory and use them for something else. They won't go to waste for sure. These are very nice rods. And the same thing goes for these bearings. Actually, I know that I will need eight of them. And I'm thinking they should be still good. I may play with them to see which ones are worn out the least, because I will need, well actually no, I'll need only 4 of them. I'll need them for the Z carriage for the Hypercube version of Printrbot. So let's see. This will be my Z carriage, like so. These parts go on top, these clamps. And so if this rod, or any one of them, is long enough to fit the redesigned printer, then I'll be good. Otherwise, I have some other 8mm rods which I'll use in place of these, and I'll just put these in my stock. So that's it for the take apart part, and in the next video I'll be putting together the new version of this printer.